I'm good. How are you doing today?
Too bad, thank you.
Good. Can't think of any way I would rather spend Saturday afternoon than doing math, except maybe one on the golf course. But
I can think of
several, I'll bet.
hundreds of things.
No, I know. All right, let me, are you out of Western Governors University? Let me sign in. Sign in error.
Sometimes you have to type it in.
Okay, and it's D. Gibbon?
No, it's capital D, A, Z, Z, A, 5940.
5940. That it?
Yep.
Okay. College algebra. Launch course. Lessons. All.
Yep.
Chapter 8. We still on chapter 8?
Yes.
Where we left off. In fact, I don't know if we got through 8.1 fully. Did we?
No.
Okay, let's go then.
So that was the next question, I think.
Okay. Okay, I'm trying to figure out why they gave us g of x. Maybe there's another question to come about g of x. So, come up with, here I guess I'm going to need my keyboard more than I'm set up for here. Let me pull it in. I had a wireless, which worked a lot better, but my wireless receiver went out. So, give me one set of x and y that satisfy that equation. Pick an x and figure out what f of x would be. Because f of x is the same as y. Understand that. So what's a real easy x to pick out? Always deal with small numbers if you can.
X squared? XX?
No. What I mean is pick a number like 0 that you're going to plug in for x.
Okay.
And then we're going to figure out what f of x is equal to. So if I plug in 0 for x, what do I get for f of x? Do the math. Here, let me do this. So that's the same as y equals x squared plus 3. Okay, this f of x is here. There's one advantage to the f of x notation, and that it allows you to do things like calculate what the function would be if I let x be 0. Well, if I let x be 0, wherever I run into it, I'm going to substitute whatever's in the parentheses,
Mhm.
and I'm going to get that. So
Okay.
f of 0 equals 3. And that would be x equal 0, y equal 3. That would be 1 point. Now, I'm just going to do one more, and then we'll go back and start filling some of these in. But while I can write on this thing, let's go further. What is f of 1? Remember, f of x is x squared plus 3. So what is f of 1?
It would be 1 and 3.
What's the final answer? What'd you say?
1 and 3.
So 4.
Yeah.
Okay, so here I would do 1 and 4. Pick another number. How about f of 2? In other words, as long as we keep our numbers small, then these are easy calculations that we don't need a calculator for. So what's f of 2 equal to?
4 and 7.
So I would put 2 when x is 2, y is 7. And I could just go 1, 2, 3, 4, 5. Might as well. But I could also, just for education purposes, I can put negative numbers in there. Let's try an f of minus 1. What would that be?
Minus 1, 2.
No, here's what you'd have to do. You'd have to put minus 1 in parentheses wherever you see x. Okay, and the parentheses are critical here. The parentheses means that you're squaring whatever's in the parentheses. In other words, you're doing minus 1 times minus 1. That turns into a plus 1. And then it's plus 1 plus 3. So it's actually 4. The same as f of 1. But if I want, I can pick an x, any number I want, and I'm going to pick minus 1. And when I do, y is 4.
Okay.
And now maybe I'll pick 3. Well, what's f of 3? Or what is y when x is 3? That's the real question.
7. Oh, sorry, 6.
Well, hold on. It's 3 squared. So that's that part's 9. Plus 3, 12. Okay. So let's go back and fill that in.
So can we use any number for x then?
You can pick any number you want. You could have picked square root of 2 because it squares to 2. So that would have given you 5 as a y. That's kind of the whole thing about functions. When you have a function, you have a independent variable and you have a dependent variable. In these cases, the independent variable is x, meaning you can pick any x you want that's a real number. And the dependent variable is y, and y is going to be equal to some number that depends on what you made x. So here, they just want us to pick 5 ordered pairs. So I'm going to do 0, 3. I'm going to do 1, 4. What the heck? I'm just going to make it simple. 2, 7, 3, 12. And the last one I'll make 4, which is 16 plus 3, 19. Okay, Okay, now they give us the other function. I knew that was coming. So let's go through the process. You give me 5 ordered pairs for this.
So could you use the same pairs that we did before?
Well, they're not going to be the same because the function's different. In other words, this is x squared minus 3. The other function was x squared plus 3.
Well, they all could be the same, but just negative, right?
Use the same 5 values for x. Yeah, we could go 0, 1, 2, 3, 4. Nothing wrong with that. So let's do that. So when x is 0, what is y? Or what is g of x? Remember, in this case, g of x is our y.
Let's say negative 3.
Okay. We're just going to go up the line. 1, what's g of x?
So that's 1 minus 3, right?
Uh-huh.
So negative 2.
And then if we pick x of 2, what do we get?
2 squared is 4 minus 1.
Minus 3, which is 1.
Yep.
Okay, and then if we pick 3, what do we get for y?
6.
And 4?
13.
All right. So here they want the sum. And, hold on a minute. When you are adding 2 functions like this, you basically add equal parts, okay? I was going to write this, but I think you understand what I'm saying, which is it's x squared plus 3 plus x squared minus 3. Well, the 3's cancel one another, and I'm left with 2x squared. You see that?
Yep.
Okay. So now what I would write would be f of x plus g of x equals 2x squared. And for a given x, we'll start same 4, 5 numbers. If the sum is 2x squared, then what is that when x is 0?
Zero.
About when x is 1.
1.
It's 2x squared is our new function.
Are we squaring the 2 then?
No? I would have had to actually say the quantity 2x squared. When I say 2x squared, it means just the x is being squared. But if x is 1, 1 squared is 1, but I still have to multiply it by the 2, so my answer is going to be 2.
Okay.
Okay, and what about when x is 2? Now what's 2x squared?
So that would be 8, right?
Uh-huh. And when x is 3,
18.
and 4,
32.
f plus g times minus 1. Well, we just figured out how to do f plus g. Just add equal parts. So what would, just first of all, tell me what f plus g would be here.
Yeah, I have no idea.
Here, let me write it out, just because I think it's more effective. So I've got essentially f plus g means x squared plus 9 plus a minus x plus 2. That's what it means. In other words, I'm just adding the two functions together. And now I'm going to simplify. Part of simplifying is removing these parentheses. And so this simplifies. There's only one x squared there. There's a minus x. And then I got a plus 9 and a plus 2. Notice that I don't have a minus 2. So that's plus 11. So that's what f plus g is equal to. Okay? Now, the next part is actually a little tricky. I guess what they're saying here is evaluated at minus 1, as opposed to multiply it by minus 1. When I first looked at this, I thought that we were going to multiply the answer by minus 1. And this is actually, that would be a strange problem. It makes far more sense to evaluate the function. In other words, here's what I've got. F plus g of x, and I have to put everything in parentheses like that, equals what we've got over here, x squared minus x plus 11. So that's what f plus g of x is. Now, I believe this is what they want us to do. Evaluate it at minus 1. Well, what are we going to do?
You just deduct, you multiply it by minus 1, or do you?
No, what you do is when you have this f of x notation, and the fact that it's f plus g of x doesn't matter, it's still f of x notation, then the rule is that whatever is in the parentheses, whether it's a number, whether it's x cubed, whether it's square root of x, doesn't matter, whatever it is, you substitute wherever you come upon x.
Okay.
So I go into the function, and there's the first place, and you want to be sure you use parentheses here. Parentheses are always going to matter when you're dealing with a negative number. And it's really easy to drop negatives, so that's another reason to use parentheses, and then go back and simplify. Now, what is this simplified to?
Uh, 2 plus 13. Is that right?
Correct. So, I guess that's what they want, is just a number, as opposed to if they really did want us to take that quadratic and multiply it by minus 1, then that would give us that. So either our answer is that or it's that. I am 90% sure that it's going to be the bottom one. In other words, I'm pretty sure that this notation wants us to evaluate the function when x is minus 1. So if I back out of here and hit 13, I think we're good on this problem. Yeah, all right. Sometimes it's hard to tell. Now that we know for sure what that is, then I don't think I have to, well, let me go through it anyway. I need writing space. All right, so first of all, tell me what g minus f of x is going to be. And it's G
I think,
minus, it's not F minus G, it's G minus F.
okay. So I think it's minus x plus 2 minus x squared plus 9.
Yeah, only in this case, I need to add the parentheses because it matters. In the last problem, we were adding two functions together. Because we're subtracting, then both of these terms need to be subtracted. So that's why I put parentheses around it. And then my next step is to remove the parentheses. Well, when I remove the parentheses, what do I get? When I remove these parentheses, what am I left with?
Minus x squared plus 9.
The negative sign has to be distributed to the 9, and that's why it was important to have the parentheses there. In other words, if I didn't have the parentheses, then it would have just been minus x squared plus 9. But, like I said, this whole quantity was being subtracted from the first function, g. Now, you might say, well, how come I didn't have parentheses there? Well, I did actually, I just didn't write them in, is because these front parentheses never much matter. In other words, it's not dependent on whether subtraction or addition is going to take place. So sometimes I get in the habit of not writing those parentheses in around the g function. But technically, this is what we were looking at. And then that turns into that. And now, what is g minus f evaluated at minus 5? And I guess the way you'd say this would be g minus f of minus 5. Tell me what I should write.
So it's minus 5 plus 2.
Hold on. Don't drop negative signs. And the best way to not drop a negative sign is to never do those two steps in one. In other words, what it really is minus, and then in place of x, I'm going to put minus 5. See, now I got two negative signs, and that's going to turn into a plus sign. So dropping a negative sign will always cause you to be wrong, unless you happen to accidentally drop two of them, and then you'd be fine. But that rarely happens. So, plus 2. And then what?
Minus. Then minus 5 in brackets.
In parentheses, right?
Squared.
And that whole thing is squared because I'm squaring the x squared, and then minus 9. Now let's go through and simplify. And we can do it term by term. And it's best probably. In other words, don't try to do this whole thing at once. It's not worth it. That's 5 plus 2 minus a 25. And no, the minus 5 gets squared first. And that turns it into a plus 25. But then you got this minus sign in front of that. So that's why it turns into a net minus 25. And then minus 9. And it's another good reason why to go back and do it one term at a time. Because it is so easy to make a mistake with these minus signs. And now we got 7 minus 34, so we got minus 27. All right. Now, this is I don't know if they mean f times g
I think so.
or if they mean f of g. The next thing we're going to get to, I'm bet dollars to donuts, would be composite functions. And in a composite function, you do a lot of f of g. And I wouldn't, that's an awful small o. In other words, typically this, what looks to be like a dot, would be a very tiny o that looked very similar to a dot. So we'll assume it's multiplication, and then we'll evaluate it. But it could be f of g, which you do an entirely different way. So let's first of all assume multiplication, and we'll come up with that. And how many tries do you get? Just one?
It's endless.
Oh, okay. But so if we miss it the first time, it doesn't let us. It lets us try it again.
Well, it will give you a different.
A different problem, but okay. At least that'll tell us whether we're doing it right or not.
Mm-hmm.
So first of all, let's multiply that times that, and do it by what some systems call FOIL, what I call ET, meaning every term by every term.
Mm-hmm.
So what do you get when you do every term by every term? And what I mean by that is take that term, multiply it by that. What do you get?
X squared multiplied by negative x.
Which is minus x cubed. In other words, if the base is the same, and it is, x and x, then what you do is you add the exponents. And there's not an imaginary, it's a real, it's just not written, 1 above that x. So when I add the exponents, I get x to the third. Okay, now multiply that times that.
Would that be 2x squared?
And I need the plus sign in front of it because it's part of a polynomial. In other words, I'm taking each of these things and adding them together. Mm-hmm. Next, I'm going to do that times that. What is that?
Minus 9x. Okay.
And finally, I'm going to do the last, which is plus 9 times plus 2.
Plus 18.
And you are including the signs. In other words, if one of these was a minus sign, I'd be multiplying by minus 2. Okay? So, we're going to assume that what we have there is what they mean by f dot g of x. Now let's figure out what f dot g of minus 2 is. So tell me what to write.
Hang on a second. I'm just writing it down.
Mm-hmm.
Okay, so it's minus parentheses minus 2 cubed,
okay,
plus 2 parentheses negative 2 squared, minus 9 parentheses negative 2 plus 18.
Perfect. Oops, can't write past that. Okay, now let's go through and simplify term by term. What does that become? Always work from the inside out. Do your exponential first.
It would be 8.
Fine. Sorry, my dog is making a commotion here. I apologize. What?
So it's 8.
Okay.
Plus
work from the inside out. What's minus 2 squared?
minus 4
Uh-uh.
times 2, right?
Oh, minus 2 times minus 2 becomes plus. Whenever you square a number, you're always getting a positive answer. No matter whether you start with a negative or a positive, if you square a number, you're getting positive. Because whether it's minus, then it's a minus times a minus, which becomes a plus. Or if it started out plus, it stays plus. So that's 4 times 2, so that's also 8.
Minus.
Now here we have two minuses that are gonna turn into a plus.
Okay, so plus 81.
Plus 18, yeah. And then plus another 18. Okay, so that is 36 plus 16, 52. That's assuming this is what they meant. Let me just check our math here. So that was minus 8. Two minuses became plus. Okay, I think we're right. 52. It's not often that you multiply these things together. That's why I wasn't sure. In other words, usually the next, and it's not very often you divide either. But this is clearly going to be division. What's the hardest to grasp is this composite function, where you actually do a f of g. It's called fog. And you also do a g of f, which is goff. And we undoubtedly will get there. But let's try this one. We haven't done division yet, so... Now, first of all, it's a little different. Here's what we're going to get here. How come I don't have my tablet anymore? Hold on a second. I don't have my... Give me a minute here. I'm trying to figure out why my pencil doesn't work anymore. Let me unplug this and plug it back in. Hold on a second, Darren.
Sure.
Usually fixes it. Unfortunately, I use a hub now, and hold on, that doesn't fix it. Restart that program. Dear. Tell me this is going to call for the dreaded reboot. I've got control using this thing. It's just my drawing. Yeah, now it's going to work. You can tell, yeah. Alright, I'm not sure what that delay was all about, but okay. This is different in that we don't actually have to do the division. In other words, what f of x divided by g of x, I can just write it. In fact, I'm not sure we had to do the multiplication in the last step, or even the addition, now that I think about it. We could have done it this way all along, I believe. Yeah, especially since they're just asking for a number. So that's what the function is. I actually could do that division. I could use long division and do it, but it's wasted effort. And now that I think about it, I think it was wasted effort on the last problem. There was no need for us to multiply those two functions together. We could have just listed it as being multiplied together, and I could have filled in my x, and I would have still got the same answer. In other words, what are we going to get? What are we going to get here? If I want to figure out what f of minus 3 divided by g of minus 3 is, what am I?
So I would say it's just minus 3 percent
Okay.
squared plus 9, and then minus 3 plus 2.
Again, minus a minus 3. That's the easiest one to drop. So many of my students drop it when you have a negative of a negative number. They instantly just say minus 3. They hate those minus signs so much that they want to get rid of them. I'm not sure what the explanation is, but I believe this is all we have to do, and that gives us what?
Minus 9 plus 9.
Hold on. This is going to end up being a plus number. Remember, anything squared is a plus number.
So it's got to be 18 then.
Correct? And that's why, just to go back a moment, that's why the parentheses matter. In other words, if I take away those parentheses, it is minus 9. Because now the 2 only applies to the 3, so you square 3, you get 9, and then you apply the minus sign. But when I've got parentheses, that means the 2 applies to everything inside the parentheses. All over, what's the bottom?
5.
So to put the answer in as a fraction, I just have to use the keypad. 18/5. Yeah, I was overthinking those previous problems. And I don't think in any of the cases that I actually have to add the functions. I could have evaluated the functions immediately without really doing any simplification of the two functions. When they were multiplied, I didn't really need to multiply. I could have just evaluated it by substituting it into that times that. Whatever number you get when you substitute the number, then multiply it by that. So, all right, I'm guessing the next one's going to be composite. No? What numbers can we do here? This is similar to the other one, but there are some restrictions to what you can let x be. Not all functions have restrictions on the domain. That's what the domain means, is what can you let x be? Well, can I let x be 0 here?
X is 1, right?
No, that's a different function. In other words, again, they're giving us two different functions, and this first question is only asking about f of x. Okay? So in the f of x function, can I let x be 0? No, I cannot. And here's the reason. You cannot take the square root of negative numbers outside the domain. So if I want to figure out what the domain of that function is, anything that's under the radical, I'm going to force it to be greater than or equal to 0. That's my starting point. No matter how complicated. It could be x cubed minus 3x squared. I'm still going to make it be greater than or equal to 0, because I can only take square roots of 0 or positive numbers. You can take the square root of 0, but can't take square root of negative numbers. So now when I solve this inequality, I get x has to be greater than or equal to 3. So I can start my ordered pairs at 3 and go up from there. I cannot go down. I cannot ever let x be 2. If x were 2, I'd be trying to take the square root of minus 1. Okay, so we're going to start at 3. That's the x coordinate. What is the y coordinate? Or what is f of x? What is f of 3? That's what I'm really asking. What is f of 3?
So if x is 3, then doesn't that become 3 minus 3?
Yep. So what is f of 3?
0.
Correct. Now, let's find another x. Well, let's just go up by 1 each time. Although that's maybe harder to put in as an answer. I don't know. We don't want to go up. I'll explain myself. I can't. My next choice of x is 4. That makes a logical choice because what is f of 4?
1.
Okay. Now notice that if I pick 5, my answer is the square root of 2.
Yep.
Well, I don't want to have to pull up my keypad. So let's go up to a value of x that gives me a whole number for the square root of it. Well, what's a good value to use for x? Here's what I mean. 7.
You could do 9.
Well, 9 minus 3 would be 6. And the square root of 6 is not a whole number. But notice that if I let x be 7, now 7 minus 3 is 4. Square root of that is 2. So if I want to keep everything a whole number, then I got to appropriately pick my x value. The next one I would pick would be 12. Because 12 minus 3 is 9, square root of 9 is 3. Don't have to fool with the keypad by picking those particular x's. I picked 3, I picked 4, I picked 7, and I picked 12. I think you can see why I picked those numbers, why I didn't pick 3, 4, 5, 6, and so forth. Because then I would have had radical signs involved. I would not have wanted to approximate and round it off to a decimal either. That's not a good solution unless you're absolutely forced to do it. All right. Now they want to talk about the other function that they listed. G of x equals 1. Now this is pretty easy to do. First of all, my x's are not limited. I can use any x I want. Why? Because there's no x on the other side. It's 1 regardless of what x I use. So if I let x be 0, the function is 1. If I let x be 1, the function is 1. You get me? Okay, so it's going to be 1, 1, 2, 1, 3, 1. In other words, regardless of what I let it be, that's true. And let me just say what this looks like. That is the equivalent of saying y equals 1. Okay? Well, that is a horizontal line that goes through the coordinate 1. And what that says is that That function is equal to 1 no matter what x is. I can let x be any number on the number line. The function is 1. So it's not really dependent on the value of x. But that's only true in cases of horizontal lines. Okay? If there's any slope at all, then there's going to be an x on the other side of that line. But in this case, it's just a horizontal line. All right. Yeah, this one, let's do the way we should have done the others. In other words, if I want to know what f of x plus g of x is, then it's obviously going to be square root of x minus 3 plus 1. I don't have to do anything else. I'll just substitute values. So that's my new y. You with me? So all he did was add the two functions.
Mm-hmm.
Now give me some pairs. Let me go back to the other page and we'll just put the answer in. It's this function minus number 1. Okay? So remember, our x is still restricted. We still can only use x's greater than 3 or equal to 3. So let's start there again. 3. What is the sum of those two functions going to be when x is 3?
So would it be 3 minus 3? Obviously 0, right?
Correct. The square root of that is 0, yeah.
And then does the 1 come back into it?
Because we're taking the sum of the functions. So all we're doing is adding that function to that function. Well, 0 plus 1 is 1.
Mm.
Now, I can again use 4 because that results in a nice round number. So when x is 4, what is the sum going to be?
2.
Okay. And again, let's go back to my round numbers. Last time I used 7. That's a good one to use again. What's the sum?
5.
Well, it's the square root of 4, which is 2.
Minus 1.
2 plus 1. So it's 3. Remember, we're adding the two functions? Okay, and again, I'm going to use 12 for x because that results in the square root of 9, which is 3 plus 1 is 4. Oh, incidentally, if I erase something or go to the next page and you're still taking notes or something, you can certainly have me back up, or do you know how to see these videos? You can, they're all recorded and I post them so that you can always go back and watch them, and you could fast forward to a certain spot if you were, questioning just one of the problems or something.
Okay.
Okay? Might be easier than you taking notes. I don't know. You know best how you learn. A lot of people love that method, and I don't quibble with it at all. So what is f of 2 going to be?
So are we substituting the...
Just into the f function. We're going to do this piece by piece. They do want f of 2 plus g of 2. But let's start with f of 2. What's f of 2?
So it's 2 parentheses squared
Okay.
plus 9.
What's that number?
13.
Okay. And then what's g of 2? Plug into this equation.
So negative 4 plus 6.
Negative 2 plus 6.
Oh, yeah, it's not
No, it's not squared. So that one's 4. So we got 13 plus 4, 17. Now, let me just make a comment. When the number you're plugging in is positive, it's not so necessary to use parentheses. Notice that when we plug it into there, if you just write 2 squared, that's the same as parentheses 2 squared. So the parentheses are almost not needed when the number is a positive number. Where they are always needed is when the number is a negative number. Okay? And likewise over here, if I just plug in the 2 for x without the parentheses, I get minus 2, which is the correct interpretation of that. All right. Now they step it up a notch. Let me just write this one, make sure I got it right, because this is what I thought they wanted us to do the first time we did this problem. In other words, I thought they wanted us to subtract the 2 functions and then evaluate. But I realized afterwards we didn't actually have to do that, but here we do. In other words, first of all, f of a. What's f of a?
Is the a the x?
Well, here's the rule. Whatever is in the parentheses, you substitute it wherever you come across x. So that's the way you interpret this. In other words, we have a function of x, but they want to know what f of a is. So it's a squared plus 9. In other words, we're going to do it just like it was a number. If I'd have said, what's f of 2, you'd have substituted 2 for x. Well, here it's an a, it's a letter, and that's perfectly fine. Okay? What is g of
a? Minus 8 plus 6.
Now, what is g of a minus f of a?
So it's the a squared plus 9 minus 8.
Be careful. We made that same mistake last time. It's this one minus this one.
Oh, yeah.
Order matters on subtraction. If we're adding 2 things, order doesn't matter. But if you're subtracting 2 things, order most definitely matters.
So they want g of a minus f of a, right?
Correct. So what should
minus a plus 6.
And I don't really need parentheses because it's the first term, but I'm going to put them around it just for clarification. I definitely am going to need the parentheses on the next term.
A squared plus 9.
You see why I need those parentheses. That negative sign needs to be distributed not just to the a squared, but to the plus 9 also. So now remove parentheses and simplify. And that's what they're going to want here. In other words, I did this unnecessarily last time. We could have just plugged into this. But they want us to give them an answer, and I'm sure they want it simplified. So first of all, remove both sets of parentheses. Well, I can remove that set without changing anything. But when I remove the second set, what does it become?
minus a squared minus 9.
Okay, and now combine, simplify that as much as possible.
So we'll
Always
be
putting the highest degree first is math convention. So I'm always putting that a squared term in the front spot. And then the next highest. So what goes next?
So why isn't it a cubed?
Well, because we're not multiplying these things. I'm not multiplying a times a squared. If I was, it would be a cubed. I'm adding them or subtracting them. And when you're subtracting them, you can only subtract like terms. I can't subtract a from a squared. This is as simplified as I get. I can't combine that at all. You can only combine like terms. If that was a plus another a squared, now they're like terms and I get two a squareds. But when you're adding or subtracting, they have to be like terms, otherwise you can't put them together. And one way to remember or think about that is that addition and subtraction is much harder than multiplication. Multiplication, I can multiply a squared times a, that's a cubed. But I can't add them or subtract them. I can just multiply them or divide them. I can also divide them very easy. And so remember that when you're tempted to try to put those together. However, I still have an a, so I still have a minus a.
Minus 3.
Right. And that's the answer we're going to want to put in, just like that. A squared minus a minus 3. A squared. I guess I have to use the keypad, huh?
Yeah.
Oh, and wasn't it minus a squared? I think it was.
No, it's minus a. Yes.
Minus a squared minus a minus 3. Okay. This looks like one we did already, doesn't it?
Is it multiplication then?
It is. This one's definitely multiplication. And you'll see why when we get to the composites. There's no way to misinterpret this one. In other words, I've got this function times this function. Whereas the other time they wrote it differently. The other time they wrote f dot g of x. And that you can interpret as either multiplication or taking the composite. And I'll show you how to take the composite when we get to that problem. If we do. I'm not 100% sure we'll get to composite functions, but I expect we will. This one is very simple multiplication, and I don't think we need to actually, they didn't say what is f of a times g of a. Had they said that, we would actually have to perform that multiplication. But this is what we're going to do. This is what I should have done last time. Just write it like that.
Mm-hmm.
And now, that's that times that, and they want f of 2, so what's f of 2? 13, and f of 2 over here is 4. We did this one. I remember putting in, didn't we?
We just did it as an addition, I think.
Oh, maybe so. Okay, because I don't know if I did put in 52 as an answer. Yeah, I think you're right. It was an addition. But it was the same two functions, and it was the same number evaluated at. Do you see how I got 13 and 4?
Yeah.
Okay. And so I got to put 52 in there. Now, they're getting a little tricky on us. In other words, the division. No, I'll bet you we don't even have to do the division on this one either. Quite sure we don't. Let's just put our answer in as a quotient. You know what I mean by that? As a ratio?
Not really.
Well, here, let me explain. In other words, here's what we're going to have. We're going to have x squared plus 9. That's f of, ooh, they got it backwards. I had it backwards. Better yet, now I know we can do it this way. G of A is on top. Well, what is G of A?
Minus 6 plus 6. Minus x plus 6.
Minus A plus 6.
Hmm.
In other words, whatever's in the parentheses, we're going to substitute wherever we see x. And now, what is f of A?
A squared plus 9.
That should be an answer we can put directly in. So it's the g function divided by the f function. The g function is minus x plus 6.
Is it minus 8?
No, we're not evaluating it. In other words, oh, it's A. Thank you. I thought you just said 8. And I says, no, it's 6. But you're correct. It's A, not X. And then f of A is A squared. So I got to use, uh-oh.
You have to put the A in first.
Oh, and then hit the square thingy.
Yeah.
Plus 9. Yeah, in other words, you don't actually have to do the division. Come to think of it, I'm not positive we actually would have had to do the multiplication even when it was A. We might have just been able to put f of A times g of A, and they might have accepted it. I multiplied it together because it actually could be simplified. Remember, we combined the plus 6 and the minus 9. So multiplying it together did allow you to simplify it. But in this case here, they're not even close to asking us to do that division.
What do you think? Should we move on?
Want to take a break or be done? I thought we were going for 2 hours today.
No. Should we just move on to the next?
Yeah. I was just going to suggest that because this is just a repeat with different functions.
Yeah, let's just do that. So go to save and end.
Whoops. So when I hit save and end, just X out of that? I guess so. It's not letting me, shall I hit skip? Maybe it's because what do you think, Darren? It's not letting me hit save and end. Still there? Ooh, you went offline at the same time I went offline. Huh. Are you back? Yeah, Darren? It looks like we lost the connection. Oh, it had you offline for a moment. Are you back on now?
Yeah, I'm back on.
Okay, so I can hang the phone up. I'll hang the phone up. Can you hear me through the speakers and mic? Might have to unmute your mic on the top left of GoToMeeting. I can't hear you. Not sure you can hear me either. Can you hear me?
I can hear you.
Now you're there. Now, okay. We got full audio?
Yep.
Okay. That happens every now and then. Technology hasn't been perfected yet, that's for sure. Okay, so let's get back to what my problem was. It was not letting me save and end. When I hit that, I get this.
So just hit continue.
I did that last time, and it took me back to this problem.
Okay, so go view results. Let's see what that does.
Guess I should have done that. When the other button doesn't work, you always just hit the other button. Okay, so
back to lesson.
Back to lesson. Here, let me minimize my GoToMeeting screen. College algebra?
No, hit yes, hit that. And then hit all. Oh, yeah, actually, yeah, you're good.
We're looking at them, I think, yeah. So we want to go to 8.2.
Right.
Okay, here's our composite functions. All right. Oh, they're going to start us off with inverse functions. Okay. Inverse functions are actually quite easy. There's only 2 steps you need to do. First step, switch the first write it as a function with y instead of g of x. Okay, so the first step is y equals 6 over x plus 2. The first step of finding the inverse is to switch the variables and then solve for y. Well, now solve that for y. And whatever I get, that's going to be my inverse function. What's the first step in solving that for y? What we want to end up with is y equals something on the left. Okay? Well, what we got now is we got a 6, we got a 2, and we got y in the denominator. We don't want it in the denominator, we want it in the numerator. So first thing, let's get rid of the 2. How do I do that? In other words, that's always the first thing, is to get rid of stuff that's being added or subtracted. That 2 is being added right now. So it's real easy to get rid of. I can just subtract 2 from both sides. Okay, so I now have x minus 2 equals 6 over y. Okay? Now, how do I get y to the numerator? This is a little tricky in the way of algebra, but when you have any denominators, whether it's a variable or not, if it's a number, the way to get, you usually want to get rid of denominators pretty quick also. And you get rid of them by multiplying both sides by the denominator. So I'm going to multiply both sides by y. And you say, well, I thought you were trying to get rid of y. Well, I got rid of from the denominator. I now have it where it should be in the numerator. It's just on the other side of the equation. But that's fine. That means the next step is y equals 6 divided by x minus 2. And that is the inverse.
So hang on a second.
Okay.
So I get the u minus 2 from the right side to get minus 2 equals 6y.
Okay. Equals 6 over y.
6 over y.
Yes, okay.
Now we want to get rid of the y, right?
I don't really want to get rid of it. I want to move it from the
Okay.
denominator to the numerator. And by multiplying both sides of the equation by y, I do exactly that. I get rid of it from the denominator on the right side, and it goes into the numerator on the left side. So now I have this step here, y times x minus 2 equals 6. And now I want to get rid of that coefficient that is actually in front of y. In other words, now I have a multiplier of y that is x minus 2. Well, how do you get rid of multipliers? You divide by x minus 2. And that turns the left side into y equals, and the right side is now 6 divided by x minus 2.
Okay.
Okay? But you can do either of those steps in either order. In other words, you could solve for x and then switch the variables. Same process. There's no real difference. But I guess what I would suggest is always do it the same way. Don't bounce back and forth. That's a great way to not remember something. If you're going to have a method to do stuff, try to do it the same way every time. So my method when I find inverse functions is always switch the variables and then solve for y. I guess with the provision that first of all you have to put it in y terms to begin with, because sometimes they give it to you in terms of g of x or f of x. I guess you could say switch the variables and solve for g of x, means the same thing. But so our answer is going to be 6 over x minus 2. I'm sorry, what? The audio is acting funny here.
So what's the negative 1 above the g? So g...
What that means is inverse. That does not have the same meaning as most negative 1 exponents would have. Typically, a negative exponent means the reciprocal. In other words, if I said, what's 2 to the minus 1, it would be equal to 1/2. Or if I said, what's 3 to the minus 1, it would be 1/3. Well, this g to the minus 1 does not mean that. What it means is inverse of the original g. When you talk about inverse functions, this is also notation that a lot of inverse functions use right up through calculus. Don't ask me why they use notation, the same notation to mean two different things, but they do. And it's not the only place in math that does that. But for example, you have the number e and you have the number e that has a completely different meaning, eccentricity. So it's fairly common. But when the topic of the subject is inverse functions, then that minus 1 only has one meaning, and that means the inverse. Okay, let me take a picture here again. So work me through finding the inverse of this. What's the first step?
Yeah, let me write this down. So we need to switch the variable, right?
Well, that is the first step, but actually there were actually 3 steps. First step is make it a function with y as the notation. That's really the first step. Instead of g of x, I'm going to make that y. Okay? Now you can do your other 2 steps. The next step?
Get rid of the -4.
Hold on. Switch the variables. So far I haven't switched the variables yet. You see why? Because all I did, I know it kind of looks like I did, because I changed g of x to y. That's not switching the variables. That is just the same notation as g of x. Okay? Now that I have it as a function using y instead of g of x, now I'm going to switch the variables, and then I'm going to solve for y. So the first thing, switching the variables. That's what we mean by switching the variables. Now solve that for y. First thing I want to get rid of. I think we're having audio issues. Your audio is a little choppy. I don't know if you can hear me or not. I think I'll call you on the phone, and let's finish the audio on the phone if that's okay with you. Yeah, it's better than having a choppy audio through GoToMeeting. Now the only thing you have to do on your end is change it to use telephone. Otherwise there's going to be interference. So go up to your audio and pick, there you go. You just did it. I can tell the interference. Ooh, I got it again. Wonder if I have to change it on my end. I don't think I can.
I changed it.
Okay, all right, all right.
So I've got x plus 4 equals 10y.
Okay, and what's the last step?
So y equals 10.
So you got x plus 4 equals 10y. And now how do you get rid of the 10?
How do I get rid of the 10?
Yeah. In other words, we want our final step to be y equals something. The second step of this method is solve for y. In other words, after you've switched the variables, then you got to solve for y. Always, and it's always a question of manipulating the equation back to y equals something. What is that 10 doing right now?
So I move the 10 on the other side?
How do I do it? What's the 10 doing right now? Is it adding, subtracting, multiplying, dividing? It currently is multiplying.
Okay.
So I get rid of it by dividing. In other words, I'm going to divide both sides by 10. That's going to leave y on the right side all by itself, and it's going to leave that on the left side. And that's what I'm going to put in for an answer. In other words, once you've solved for y, once you switch the variables and solve for y, then you get a completely different looking function. It's not that function anymore. It's whatever you get when you solve for y after switching the variables. So x plus 4 divided by 10. Now, technically, it really, I shouldn't really call that last thing y, because it's not the same as the original g of x. Okay? Let's do one more of these. These, if you haven't done a lot of these can be a little challenging, especially the algebra part, when the variable is in the denominator. Although we did one just like this. So let's find the inverse. What's the first thing I should do?
Switch the variable.
What's the first thing I should write?
Y equals 7x over 5.
7 over x plus 5.
Yeah.
Now that's, I didn't switch the variables yet. So that's real, this is the first step, is turn g of x into y. The reason that's not on my list as the first step is because frequently you're given the function as y equals. You don't have to do that. It's only in this lesson plan that all of the functions they're giving us are using function notation. So instead of using y, they're using g of x. So the first thing I really want to do is make it a y function, not a g of x function. Now I can do my next two steps. So switch the variables and solve for y. What do I get when I switch the variables?
X equals 7 over y plus 5.
Now solve that for y.
So the 5 minus x equals 7 over y.
Well, not quite, but close. X minus 5. Remember, I'm subtracting 5 from both sides. Okay. Now, get that y out of the denominator and get it into the numerator.
So would it be y equals 7 over x minus 5?
Okay, doing two steps in one, yes. Nothing wrong with it if you can do it. And that's going to be what we're going to put in as an answer. 7 over x minus 5. And it's also, this would really be proper to now go back and change it not to g of x, but to g of inverse x, like that. This really is more correct than calling it y, because I originally said that this y was g of x. And so to come up with a new function that I also call y is inappropriate. But I've always learned to do my inverse functions like this, where I turn it into y, then switch the variables, solve for y, knowing all along that the y you get at the end is not the same as the y you started with. All right, so 7 over x minus 5. Okay. This is an easier one, and the reason it is because I got no variables in the denominator. So I don't have to take that step. So tell me everything I should do here. Line by line.
So got y equals 7x minus 2.
Okay, that's our original function, okay.
And then I got minus 2y.
Hold on. Switch the variables. You didn't switch the variables. In other words, I'm not switching the variables when I turn it into a function of y. That's not switching the variables.
Okay, so x equals 7y minus 2.
There you go. Next step.
And then x minus 2 equals 7y.
Well, be x plus 2. In other words, I got to get rid of that 2, which is currently being subtracted, so I got to add. Always doing the opposite of what
X
the...
equals 7y.
Okay. Now what's y equal to?
Y equals 7 over x plus 2.
I think you meant that. x plus 2 divided by 7. And that's also equal to f inverse of x, not really y. Okay? In other words, this started out as f of x, and I called it y for just, that's a tool I use for solving this problem. I didn't have to really do that. I could have left it called f of x, and then when I would have switched the variables, I would have called it f inverse of x. But it's less confusing to me if you use y, just x and y. So we have x plus 2 over 7. Guess I should just leave that keypad up. Especially since all of our answers are going to be fractions. Okay. Now, of course, when I leave the keypad up, it gets photographed. Or when I take a screenshot, it gets the screenshot. So now I can write on that. So let's do this one.
So it would be x equals 9y cubed plus 1.
Okay. Next step.
It would be x minus 1 equals 9y cubed.
Good. Next step.
Would it be,
You want to get rid of the 9 before you get rid of the 3. That's just the order you want to go in.
So is that negative 9 on that side? Move it over to the
No,
left
I got that 9 as a multiplier right now. So what's the opposite of multiplication?
division.
Then I got to divide both sides by 9. That's now going to be y cubed. Now how am I going to get rid of the 3?
The 3.
In other words, I haven't solved for y yet. I've solved for y cubed.
So that would leave us with what?
Well,
Y cubed.
if I take the cube root of both sides, then I'm left with y. Okay? And I can write that a couple of ways, but I can already tell your keypad's not going to like this way. There's taking the cube root of the right side, there's taking the cube root of the left side. Okay? What that's going to give me on the right is just y. When I take the cube root of something being cubed, I get whatever that something was. However, I don't see any cube root capability over there, but you can do this using fractional exponents, which is maybe a better way to understand it. In other words, instead of taking the cube root, I'm going to take each side to the 1/3 power. And that's the same as taking the cube root. It's just writing it different. Instead of writing a radical sign with a 3 in it, I write it as 1/3. Square root is 1/2. Fourth root is 1/4. So anything that uses a radical sign, you can write as a fractional exponent, and that's going to be better here because this keypad, I don't see any capability to write cube root. But I do have a capability of writing fractional exponents, I believe. We'll see when we try to put this in. But this is going to be my answer because the right side now becomes just y. Remember how you handle two exponents. You multiply them together. And that's why I know that I want to take both sides to the 1/3 power. I know I want to end up with y, so I've got to take it to a fractional exponent that when multiplied by 3 equals 1. And that would be 1/3. Now, all we got to do is figure out how to get this in. And it is that whole thing to the 1/3 power. X minus 1 over 9 to the 1/3 power. X minus 1 over 9. So I'm going to start with parentheses.
And do your fraction.
So it's x minus 1 over 9 and now, there we go, and now these are almost like ancient and with today's technology, because they figured out how to do all of this without using one of these keypads. In other words, my new TI Inspire goes straight to, if you go to, too hard to explain. But we got it in there. Was that our answer? Was that supposed to be it, x minus 1 over 9? I think so. One of the problems with doing it this way is as I lose the answer that I had figured out. I can't see it anymore. All right, composites. Now we get to the good stuff.
What is that F? What's that thing between the F and the G there?
That's the composite sign. That's what I didn't know, whether it was a O or a period the first time we saw it. Notice that there's not a lot of difference between what we're looking at and this, and yet they have drastic meaning differences. This one means multiplication. This one means composite. And I will show you what that means here. If you have two functions, the easiest way to explain it is this way. What is f of 3?
What is it?
Uh-huh.
What is it?
Yep, what's f of 3?
So the 3, and then the 3 in the parentheses minus 1.
Okay. So what's that number? 9 minus 1 is 8. Okay. Now, if I said to you, what is f of 10x plus 7 in the parentheses, now tell me what I should write exactly.
So there's the 3, and then the parentheses 10x plus 7 minus 1.
Correct. That's what this means. In other words, g of x is this function, 10x plus 7. So what it was really asking me to do was this. What is f of g of x? So that's what that means. I actually kind of did this backwards. This fog of x means this, f of g of x. And I can also take g of f of x if I want. But this particular one, they've got the f before the g, so it's definitely f of g of x. The next step is to plug in the g of x, so you have f of 10x plus 7. And the next step is to plug in the 10x plus 7 into the function, and that's what gives you this over here, but that needs to be simplified, notice. In other words, what I've circled can definitely be simplified because I got a number that's going to come out of this, and I got this minus 1 over here. So let's go ahead and simplify this. What's that become?
Is it 30x plus 1?
Minus 1. Now simplify it further.
30x plus 20.
There's our answer. That is what f of g of x is, or commonly called fog. Fog of x means f of g of x. Maybe they call it fog. Maybe they call it fog because it usually puts the students into a fog.
Hang on a second. So looking at this equation, right? So we're inserting g, which is the 10x plus 7.
Exactly.
In the place
Of g of x. That's what g of x is. They're equal.
In the place of that x after the 3, right?
Well, hold on. We got two things going on here. Let me erase some of the extra stuff I got confusing, mucking up the picture here. I wrote it twice, and I kind of did it in backwards order accidentally. First of all, that means this. You with me?
Yes.
Now we substitute g of x, which is 10x plus 7. So we substitute 10x plus 7 in place of the g of x. So now we got that. Now, because it's an f function, we're going to go to this f function right there, and wherever we see x, we're going to substitute 10x plus 7. So it's going to be 3 times 10x plus 7, and this is exactly what we did the first time, minus 1, and that simplifies to that, 30x plus 20. So the answer is 30x plus 20. But that's the sequence we went in. First of all, interpreted that properly, more properly. It makes much more sense if you write it as f of g of x. I don't have to explain it if I write it like this, correct? Whereas fog of x needs explaining. If you don't know what that means, then somebody has to tell you. Well, this doesn't really need explaining. That means you're taking f of, and instead of x, you're taking f of g of x. And g of x is another function over here. So you're really taking f of 10x plus 7, which means whatever's in the parentheses, you substitute in the f function only. In other words, we're done with the g function. We're going to substitute only in the f function. Now, they also could have said, what is g dot f of x? And that means g of f of x, which is slightly different, notice. This is f of g of x. This is g of f of x. So I would do the same thing. This becomes g. Well, my f of x is 3x minus 1. And now I would substitute 3x minus 1 into my g function. All right. So we got to put this answer in. 30x plus 20. Oh, I can finally put one in without the keypad. All right, now they want Goff.
Which is what you just talked about, right?
We did. I just went through it. First of all, let's write it in the proper notation it should have been written in the first place. What is that? G of what?
G of x.
G of f of x. That's what Goff means. In other words, you still have to reference both functions. it's still a composite function. What a composite function means is exactly this. You're combining two functions. And we're saying that that combination is going to be g of f of x. Okay, now what's the next row going to be? G of what?
So it's 10.
No? What's f of x? Fill in f of x. There's f of x.
3x minus 1.
Okay. Now, let's figure out what that is. Now we go to our g function. Tell me what I should write.
So equals 10, parentheses, 3x minus 1 plus 7.
Perfect. Simplify.
Hang on a second, I've got to write this down.
Okay.
So 30x minus 10 plus 7.
Which is 30x minus 3. So that's what we want to answer. You got everything?
Yeah.
Okay.
It's really not that bad, really.
No, it isn't. Once you figure out the pattern, it's always the same pattern. The method is pretty much the same. Now, that really is true with a lot of math. It looks confusing the first time you go through it, but once you do the same thing over and over, you figure out the method, and then it gets kind of easy. So this looks like they're backing up a little bit. And I understand why. Here's what the next two questions are going to be. This question, and then they're going to say, what is f of f inverse of x? In other words, the next question, they're going to do this. This is my guess. We'll see. That's the only reason they have for backing up. That's the next thing they're going to ask us. After we solve for f inverse of x, they're going to ask this. So let's solve for f inverse of x.
We've already done these, right?
Yeah, and that's why I said they're backing up, so it's tempting to skip, but not quite so fast. They're trying to make a point here, I believe. We'll find out. Let's do this one again.
So y equals 3x minus 2.
Okay.
X equals 3y minus 2.
Okay.
X minus 2 equals 3y.
Whenever you're moving that number to the other side of the equation, you got to change its sign. That's the way I always look at it. There's two ways to look at algebra. One is I'm going to add 2 to both sides. The shorter method, the one I really actually use in my head, is I'm going to take anything that's being added or subtracted, I'm going to throw it on the other side, and I'm going to change its sign. Automatically, that becomes plus 2. That's equal to 3y. Now what's y equal to?
Y equals 3 over x plus 2.
You're saying it wrong. It's not 3 over x plus 2. It's x plus 2 over 3. You see the difference?
Why is it?
Because I've got to divide both sides by 3. I'm not multiplying both sides by 3. I'm dividing by 3. If I divide the right side by 3, I got to divide the left side by 3. That gets rid of the 3's, leaving y all by itself on the right side, and gives me this as my answer. Maybe it wasn't just you were saying it wrong. That's why. It's x plus 2 over 3. Okay? So let's put that in. X plus 2 divided by 3. Not quite yet. Maybe, I don't know what that problem was doing there. It seems like that they switched to composites, and then they went back and had us do an inverse problem. And there's a good reason why you would do that. It's just hasn't come out yet. The reason is this. I'm going to just tell you right now what it is and why they should have done it. When you take the function of its own inverse, like that. In other words, this isn't Goff or Fogg, it's f of f inverse of x. That is always equal to x. As is this, the inverse of the original function. That's also always equal to x. And in fact, that is the definition of an inverse function, is the composite of the function and its inverse is always equal to x. That's why I thought, since they asked us what that inverse was, the next question was going to be, what is f of inverse f? And we were going to solve it, and it was going to come out to be x. And that shows that one is an inverse of the other. But that didn't appear to be where they're headed. So we'll get there when they decide to put us there. So first of all, what's f of g of x? Finally, they're using notation that I like better. In other words, they didn't use that silly FOG, but they wrote it out the way they should have the first time, f of g of x. So what's the next thing I should write?
3x plus 2.
Okay. What's the next thing I should write?
So it would be 4, 3x plus 2, parentheses, squared.
And then don't forget to always bring in those numbers that are still there also. In other words, there's a plus 2 that was there originally. We have to keep that in there.
So that gives us 12x plus.
Well, hold on. You've got to do these in the right order. We can't distribute that 4 until we've squared that expression. I don't think they're going to accept this as an answer because there's a lot of simplification we can do. So the first thing we have to do is square 3x plus 2. So let's do that step first, and we'll put the answer in those parentheses, and then I'm going to add 2 to it. So square here, down here on the left, 3x plus 2 times 3x plus 2. That's what 3x plus 2 squared means. What's that give us? 9x squared. In other words, that times that. Got to multiply the 3 times the 3 and the x times the x. That's why we get 9x squared. Okay.
Plus 4.
No, the next one you should do is that one. And this is another case of always following the same pattern. That's really why they teach FOIL in school. It isn't because it's so valuable, it's because they don't want you mixing up and going in different methods. They don't want you multiplying 2 times 2 next. We'll get to that, but not next. They want you multiplying 3x times 2, which is 6x. Then they want you multiplying this 2 times that 3x, which is another 6x. And then finally, the last step is where you multiply the two numbers together. Now you can always, almost always, combine those two middle terms. They're apples and apples. So my f, or what goes here in the parentheses now, after squaring it, is 9x squared plus 12x plus 4. You with me?
Yep.
Now, let's keep simplifying. What's the next step in simplifying?
So we gotta multiply these by 4, right?
Correct. You've got to distribute that 4. What's that give me?
Do we square that 9 squared? So
No,
like 4 times 36.
it's just 4 times 9. Yeah, so it's 36x squared. Now distribute the 4 to the second term.
Plus 48x.
And now to the constant.
16 plus 2.
So I'll just write 18, save one row of writing. And that is our answer. I can't minimize this without making it go away. Do you have that written down?
Yeah.
36, 48, and 18. 36, 48, and 18. Oh, I got to put the x first. X squared, 36, 48, and 18, all with plus signs, right? Okay. They want us to do the opposite. This really, actually, is pretty good the way they do it, especially if you're being tutored, because I get to show you how to do the first one, and then you can apply that in doing this one. So tell me everything I should write.
Okay, so G equals.
Not yet. In other words, is all I'm doing is rewriting that. What does that rewrite to?
So isn't it the same as what's in front of the box there?
Well, I need the parentheses. You said G equals. It's
Okay, so
G of what? What goes in the parentheses? It's not f of x, it's what?
G of x.
No, it's what f of x is equal to.
Oh, okay. 4x squared plus 2.
There you go. That's what I'm trying to get at. That's the first thing you need to write. That's what that means. That's what g of f of x means, is it means g of 4x squared plus 2. And now, what's that equal to?
Let's write this down.
Mm-hmm.
All right, so it would be 3 parentheses 4x squared plus 2
End parentheses is the way you verbalize that.
plus 2.
Right. Perfect. Now the only thing we have to do is distribute and simplify. We don't have to square this one, so this is easier.
So it would be 3.
Next step would be to distribute that 3.
So is it like 3 times 4?
Yeah, and by distribute, what I mean by that is you're going to multiply that 3 by both terms and add those two things together. So, in other words, you're going to multiply it by that term, and then you're going to add that to whatever you get when you multiply it by that term.
So the 12x squared plus 6 plus 2.
Correct. So there's our answer. answer, 12x squared plus 8. 12x squared plus 8. You tell me when you're comfortable skipping. It seems like they're in the repeat phase. I'd say it's probably worth doing at least one more of these. You think?
Yeah.
Okay. So, start from where I'm pointing, if you can't see. Start from that.
So it's that parentheses 2x plus 1.
Very good. And
that equals 4 parentheses 2x plus 1 in parentheses squared.
perfect.
Minus 4.
Perfect. Okay. Now let's expand that. Now,
This is why you have to do multiplication, right? You can square it.
right. In other words, we do have to do the squaring first. There's an order of operations. The PEMDAS, I don't know if you know that expression, but it's parentheses, exponentials, multiplication, division, addition, subtraction. That's the order of operations. So you're always doing exponentials first before we're applying that 4, because that 4 is not being squared. So if I distribute that first, I make a bigger number that's to be squared. Well, we wouldn't want to do that. So I guess, I don't know if it's worth teaching you how to automatically square stuff. Well, you have to do it so often is the only reason. But anyway, go ahead. You can always do it manually like this.
So what I have is 4x plus
4x squared. In other words, when I do that multiplication, I got to multiply the 2 times the 2, and I got to multiply the x times the x. And that becomes 4x squared. Okay?
and then I have plus x plus 2x plus 2.
Plus 1. 1 times 1 is 1. Okay, and then those middle 2 terms almost always combine. In this case, what's that?
4x squared, 4x plus 1.
Right. 4x squared plus 4x plus 1. Okay, and now that's what we have to multiply by 4. In other words, that's what goes inside there now.
Yep.
Let me erase all this so we have room to write. And now distribute that first 4.
So I got 16x squared plus
X.
16x plus 4 minus 4.
Which is 0. So that's our answer. 16x squared plus 16x. 16x keypad 2 right arrow plus x. Uh-oh. Oh, plus 16x, huh?
Just hit try again.
I typed it in wrong. Well, maybe it's going to let me. It was 16x, right?
Yeah.
Okay, good. Gotta be careful on these computer entries. Slip of the brain is all it takes. All right, my brain is even fried a little bit. Yours must be too.
Yeah, I think we're good. So go to save and end practice.
What's that?
Go to save and end practice.
Okay, yeah. What did I do? I hit view results.
Yeah, that's right.
And then
Back to lesson.
back to lesson. I guess it doesn't do any good to sign out until you get back to that first page, huh?
Hey, let's go back to college algebra. Let's just see what's left here.
Okay.
And then number 8. Then scroll down.
Okay, let me have a look at this. We pretty much covered 8.2. 8.3, not that hard. Logs. The moment I saw this chapter, I started working with you with logs. So I've already given you a lot of the explanation of logs. Once you get logs, logs are actually pretty easy also. They really are. They're not that tough once you get the method. That's all you have to memorize again. That takes us through the properties of logs, again memorizing. Common logs, that's easy. I'm going to guess 2 hours to finish this next session.
2 more hours, right?
For this section 8, chapter 8, I'm guessing. Maybe 2 hours. I would think we could make a pretty good dent in that. At least doing it the way we're doing it, where we don't do every problem, but just until you're comfortable, you know how to do it.
So here's the thing, right? Talking to my college, there's a pre-assessment that you take, right, before you, and you have to score 70% on the pre-assessment before you can take the exam.
Okay.
So they want me to take the pre-assessment early next week to kind of see where I'm at.
And it covers all 10 chapters?
It covers all 8 chapters.
Oh, so all we got to do is get through chapter 8 for your pre-assessment exam.
Yes.
Okay. Well, I think we're looking at a couple hours, maybe not to make you proficient, but a couple hours of tutoring along with maybe a couple hours of you working on the problems after the tutoring sessions. I think that's all it'll take to get through chapter 8.
All right, so I can go tomorrow. I'll go back to chapter 8.1 and 8.2 again.
Okay.
So maybe we'll look early next week.
Okay.
To finish off chapter 8, and then maybe middle of next week I can try the pre-assessment.
Okay. Sounds good.
And we'll see where I'm at.
Yeah. Logs are confusing to a lot of people just because they don't like the word. But once you understand what they are and how they work, they're not that hard.
It's all confusing, David.
Well, I was going to say, the conic sections, chapter 9 and chapter 10, those are going to be, conic sections is a couple hours all on its own. And chapter 10, that's probably a couple hours on its own also.
Yeah, but that's still stuff that I have to cover.
Right. No, I understand. I just kind of trying to get a feel for how much more you're looking at in terms of tutoring.
So maybe I'll look at your schedule and book something. I'll pay you for what I owe you for the last 3, and then I'll book something.
That sounds fine. That sounds fine. There are spots open next week. I am not fully booked up yet, so there should be times for you.
All right. We'll do that, and then we'll see how my pre-assessment goes towards the end of the week.
All right. I'd be confident. I think you'll do just fine. I do. Once you get it, once you cross a certain line with these things, you know it at least for a short period of time. I don't know that you retain it or how long you retain it, but I guess we'll find out.
Yeah, that's my challenge, right? I mean, I know I can do it. You know,
Yeah.
we're talking about
Yeah.
it's like,
At some point, what we would want to do, and I haven't really mentioned this before, but rather than work chapter by chapter the way we're doing, at some point we would want to sit there and do a general review ourselves, so that we go back over and review all 8 chapters and randomly select problems pretty much from each chapter. And when you can master that, that's when you've learned it. In other words, when you can do it in any order, kind of.
yeah. All right. Well, look, I appreciate your time today. I'll schedule something here, and we'll talk early next week.
Sounds good, Darren. Have a good Easter tomorrow.
Yeah, and if you just log out, then I can log back.
Oh yeah, I forgot. Let's see. I can log out. No, I got to go to the college. I think I got to go to the dashboard, but
Actually, you can just hit that X near Hawks Learning up the top there.
yeah, it always forces me back to hit what?
Just close that tab.
Oh, just close the window?
Yeah.
The whole thing? Okay, like that. All right. All right, Darren. Talk to you next week.
Yeah, appreciate it. Thanks.
Sure. Bye-bye.